is the first question that you had was from Learning Target 13.4. It says, the Learning Target literally says I can use the heat equation to calculate a difference in thermal energy. So two things that come to mind here is that I see that there are two different temperatures. I see a initial temperature, which is this one, and I see a final temperature, which is this one, and it's just calculating a thermal difference in energy. So the heat calculation or heat equation is this one right there. So I'm going to identify my variables like I always do. Q is equal to mass times specific heat times change in temperature, which we've always identified to be TF minus TI. So going through the problem here, I see that it says how much energy would be needed to raise the temperature of 500 grams of silver. So I'm going to have 500 with a decimal point grams of silver. And I'll figure out the CP in a second, but I'm just going to identify my TF and my TI, which I already did. It's starting at 150 degrees Celsius, and it's going to go to 450 degrees Celsius. So I'm going to have 450 degrees Celsius with a decimal point there, minus 150 degrees Celsius with a decimal point there. Now, the thing of it is that in this problem, I need to first of all identify what state of matter the silver is in. And I do that by going up to look at the data that I've been provided. So in this problem, I see that the melting point is 962 degrees Celsius. So the melting point / freezing point is 962. And during the entire problem, the temperature never gets above that. So that tells me that this is going to be a solid. Because the temps in the problem never get above the melting point. So that tells me that the CP that I have to use here is the 0.235 because that's the specific heat of a solid. So that's the 0.235 joules per gram per degree Celsius. So now I'm just going to use my formula. Q is equal to mass times specific heat times change in temperature. So I'm going to substitute in the 500 grams. I'm going to substitute in the 0.235 joules per gram per degree Celsius. And then TF is going to be 450 degrees Celsius minus 150 degrees Celsius. And now all is left to do is plug it into my calculator. And when I plug this into my calculator, I get a really, really large number. I get something like 35,250 joules. Now, this problem does not ask me to convert it to kilojoules, but I'm going to anyway, just so that we get practice with it. So I'm going to take that and I'm going to convert it to kilojoules by saying that 1 kilojoule is equal to 1,000 joules. And so then when I do that math, I get something like 35.250 joules. Now, sig figs is something that we're going to be assessing on this particular quiz. So looking back at the problem, I see that my mass is in 3 sig figs, my CP happens to be in 3 sig figs, and both of my temperatures have to be in 3 sig figs. So if I wanted to leave this as joules, which you could have done, you'd have to write it either as 35,300 joules or 3.53 times 10 to the 4th joules. Both are correct. If you wanted to take it in kilojoules, you would just take the 35.3 kilojoules and call it a day. So both of those answers are correct, but they are the answers that are associated with the appropriate number of sig figs. Do we have any questions about this one? Yes, sir.
What would the CP be if it wasn't a solid?
The question was, what would the CP be if it wasn't a solid? Well, in this problem, this particular situation, we did not provide a CP. But if it was a gas or a liquid, you'd have to choose the appropriate CP, which is, I guess, that's a good question because when I'm looking at these problems, I'm trying to decide what state of matter I'm in, and that's pretty important. All right, so I'm going to stop